Hey, space explorers, ever heard of something so powerful and mysterious? Something so powerful it can even trap light? Today, we're diving into the universe's ultimate traps, black holes. Imagine if you could take something huge, a giant star, way bigger than our sun, and squeeze it down, down, into something tiny. All its life, that star was in a giant battle, nuclear fusion exploding outwards, and its own massive gravity pulling inwards. But when the star runs out of fuel, gravity wins, and it wins big. The star collapses, triggering a mind-blowing supernova. But at the center, the star's core keeps crushing down. Think about it this way. A bowling ball on a trampoline makes a dip, right? Now imagine that bowling ball kept all its weight, but shrank down to this tiny marble. It would make a ridiculously deep, steep pit. So deep, nothing could climb out. That, my friends, is basically a black hole. It's not a hole at all. It's an incredibly dense, super heavy object where gravity has gone absolutely crazy. Its gravity is so powerful, not even the fastest thing in the universe, light, can escape. And that's why we call them black. They don't reflect any light, so we can't see them directly. So what's inside? All that mass gets crushed into an infinitely tiny, infinitely dense point. We call this the singularity. The black part we see is just the boundary, like an invisible fence. Scientists call it the event horizon. It's the point of no return. If you stay outside this fence, you're fine. You could actually orbit a black hole safely, just like our Earth orbits the sun. But cross that line, whoosh, you're in, and there's no going back. You must fall to the center. And what would happen if you fell in? The gravity at your feet would be so much stronger than the gravity at your head that you would be stretched out like a piece of spaghetti. Scientists actually call this spaghettification. So if they're invisible, how do we know they exist? Well, we play cosmic detective. We can't see the black hole, but we can see how it affects everything around it. We look for stars zipping around an empty spot in space at insane speeds. And sometimes, as gas and dust get pulled towards the black hole, they form a massive spinning disk. As it spirals faster, friction heats it up to millions of degrees. It glows super bright in X-rays, which our telescopes can see. And these monsters come in different sizes. Stellar black holes are born from one star and are maybe 10 or 20 times the mass of our sun. But at the center of most galaxies, including our own, lurks a supermassive black hole. These are millions or even billions of times heavier than our sun. But don't worry, they aren't cosmic vacuum cleaners. A black hole won't suck you in unless you get really close. If our sun was replaced by a black hole of the same weight, Earth would be fine. We'd just keep orbiting in the cold and dark. Black holes are some of the most extreme, mind-bending, and incredible objects in our entire universe. If you loved learning about these cosmic giants, smash that like button and subscribe for more. What should we